Okay, in the last session we discussed about AWK command and what is the syntax of script and regular expressions. We have different kinds of regular expressions. Okay, so one of them arithmetic expressions. Okay, so arithmetic expressions can be built by using arithmetic operators. Okay, so these are regular expressions. Now arithmetic expressions are built using arithmetic operators. So we'll see what are the arithmetic operators in this Unix. So most of the operators are like C operators. All C arithmetic operators are supported by AWK command. Okay, so like suppose in C we use plus for addition, minus symbol or operator for subtraction, asterisk for multiplication, for division operation slash, for modulus operation percentile. Okay, so these operators are for arithmetic operations like plus, minus, okay, asterisk, slash, percentile. So next we can use cap symbol. So this is like for power. Suppose x square, y square, a power 2. Okay, so for that you can use this cap. Okay, suppose like some example, a some variable a cap 2 means it is equals to a square in our mathematical expression. Okay, so this is for power. So next, apart from this, we have some increment operators like plus plus and minus minus. So these two are increment or decrement operators. So it will increment or decrement the variable value by 1 or by 1. Okay, suppose if I say a plus plus, there is a variable a plus plus, it can be capital or small, a plus plus. So this will increment a variable value by 1. Suppose take this example, if a value equals to some say 5, okay, so a plus plus, after executing this a plus plus, a value will be incremented by 1, so it will be 6. Here if you say print a, so if you print this a value, it will print 6. So here the value will be incremented with this increment operator. So this is exactly similar to, it is equals to a equals to a plus 1. A plus 1. We are incrementing the variable value by 1 using this plus plus. And using minus minus, we can decrement the variable value by 1. Okay. Now the second thing is, if the operator plus plus, that is increment operator, is placed after the operator operand is nothing but the variable or some constant value. Okay, so here this is operator operand, this operator is placed after this operand. So this type of incrementation is nothing but post incrementation, post increment. If you place this operator plus plus operator before the operand, plus plus operator before the operand a, so this type of increment is nothing but pre-increment. Okay, in the same way minus minus also, if you place minus minus, that is decrement operator before the operand, this is pre-decrement. Okay, if you place after the operand, that will be post decrement. Okay, so these two are increment and decrement operators. In increment and decrement, we have two kind of operations like post increment, pre increment, post decrement, pre decrement. Okay, so what is post and pre? Based on the operator. If the operator is after the operand, that is post increment. If you use this individually, there is no difference, like a plus plus or plus plus a. Anyway, next statement, a value will be incremented. If you use this in an expression like, suppose c equals to plus plus a plus some 5 plus b minus minus. Okay, suppose b. Now if you are using this particular increment operator in an expression, then it will differ. Okay, so there is a difference between, like suppose c equals to a plus 5 plus b. Okay, so here we have two kinds of operations. One is c equals to plus a plus 5 plus b. Here we are using pre-increment. In this case we are using post-increment. Now assume that suppose a value is some 4. Here also I am taking a value some 4. Okay, now after executing this expression, c value will be, so this one is pre-increment. So first a value will be incremented, then the expression will be evaluated. So first increment the a value. So that is 4 plus 1. So a value will be 5. 5 plus 5, 10. 10 plus b value. Suppose b value, assume that I am taking b value some 5. Okay, or suppose 2. Now see, plus a, this is pre-increment. Pre-increment means first increment the variable value, then evaluate the expression. So here first a value will be incremented by 1, so it becomes 5. 5 plus 5, 10. 10 plus b value 2. So the result will be 12, 1 to 12. Now in this case I am taking a value same 4 only, b equals to 2 only. Now if you evaluate this expression, the value will be, see, here this is post incrementation. In the case of post incrementation, first expression will be evaluated, then when the cursor goes to next statement, then a value will be incremented. So that is post incrementation. First expression, then increment. In the case of pre, first increment, then expression. So here this is post incrementation. First a value will not be incremented, so it will take a value 4 only. Okay, so 4 plus 5, 9. 9 plus b value 2. Okay, 11. Okay, when you go to next line, a value will be incremented. Now here a becomes 5. Okay, so that is the difference between pre and post. If you use individually, like a plus a, there is no difference. Okay, anyway when you go to next statement, a value will be incremented, whether it can be post or pre. But if you use in an expression, there is a difference. Okay, so that difference is, in the case of pre-increment or pre-decrement, first expression will be evaluated, then that particular variable value will be incremented or decremented. So in the case of post, first expression will be evaluated. Sorry, I repeat. In the case of pre, the increment or decrement operation will be done first, then expression will be evaluated. The vice versa in the case of post. Okay, first expression, then increment or decrement variable value. Okay, fine. So these two are increment and decrement operators, same as C language. Next one, short form of operators. We have some short form of operators, like suppose take this expression a equals to a plus 10. Small a, assume that everything is small. Okay, a equals to a plus some 10. The same statement we can write like in C language or in AWK command also. So you can take, instead of writing this twice, you can use short form operators, like we have plus equals to. Okay, so plus equals to, so a plus equals to 10. So this is similar to a equals to a plus 10. In the same way, we have like b asterisk equals to suppose some 34. So this statement is exactly equals to b into 34. Okay, so this statement can be right here. These two names are same, variable names are same, so you can eliminate this one and bring this asterisk before equal to symbol. Okay, so that is short form operators. So here we have some short form operators, like for all arithmetic operations we have short form operators: plus equals to, minus equals to, asterisk equals to, Okay, division equals to percentile equals to, okay, so we can use even cap also, cap equals to, okay. So these are all, this is power symbol, power operator, okay, fine. So these are all short form operators in AWK command. So these are all C, it also support, I mean these are all C operators, the same operator supported in AWK also, okay. So these are arithmetic operators available in AWK command. All these operators are arithmetic operators. So arithmetic expressions can be built by using arithmetic operators, okay. So here we are using two terminologies, one is operator, another one is operand. So this particular symbol is nothing but operator, and whatever the variables or constants we are using, that is operand, okay, fine. So next one, relational operators or relational expressions. So here relational expressions can be built by using relational operators. So we'll see one example what is relational expression, like A greater than B. So this is one relational expression. Here we are comparing or we are checking the relation between A and B is greater than or not. Okay, so this is one relational expression. In this expression, A and B are operands and this particular symbol is operator. So we can build these relational expressions by using relational operators. We'll see what are relational operators in AWK command. So here relational operators are less than, greater than, less than or equals to. So there should not be any space. These two. Suppose if you see this, you can find some two symbols, but in AWK command, these two combinedly, it is a single operator. Okay. There should not be any gap or space between these two symbols. Okay. It is only single operator. So this is less than or equals to operator, greater than or equals to operator, equals to. For comparing equality of two, you can use this equal to operator, and not equals to. Okay. So to compare two elements are not equal or not, you can use this not equals to. So this is not equals to, equals to, greater than or not, greater than or equals to, less than or equals to, greater than, less than. Okay. So here examples like A less than 10. So you are comparing one variable value and constant value 10. Okay, whether both are, A value is less than 10 or not. Okay, next one, like B greater than C. So here you are comparing two variable values, like B and greater than B, C. So B is greater than C or not. If it is greater than C, if B value is greater than C, then the result will be true. Otherwise, it is false. In the same case here also. If A value is, suppose I am taking A value, say some A equals to 4. Okay. Now this regular expression will check A less than 10. What is A value? 4. 4 less than 10. Yes, 4 is less than 10. So the result of this expression is true. The result of this expression is true. Suppose if you take A value some 45. Now in this case, the result of this expression will be false. Okay. So A less than 10, 45 less than 10. So 45 is not less than 10. So the result is false. Okay. So in this way it will compare two elements. Next one, less than or equals to. Suppose I am taking A value some 6. The expression is A less than or equals to 6. A value is 6. Okay. Now A value I'm taking 6 and the expression is A less than or equals to 6. This condition is true. First it will check whether this A is less than 6 or not. No, it is not less than. Equals to or not. Yes, it is equals to. Okay. So if either one is okay or satisfied, then the entire result will be true. The result will be true. Okay. Suppose if you take some A value 2, 2 less than 6, yes, 2 less than 6. Okay, less than or equals to. So less than or equal to either one. The A value can be either less than 6 or it can be equals to 6. In that case, the result will be true. Otherwise, it will be false. Okay, like if you take some A value 27. So first it will check A is less than 6 or not. 27 6 or not? No. 27 is not less than 6. Next it will check equal to or not. 27 equals to 6? No. So in this case, the result will be false. Okay. So if you want to make it true, either one, either less than or it can be equals to. Okay. So greater than also, like suppose B greater than or equals to some C or some 5. Okay, any value. So it will compare, sorry, here greater than or equals to. Okay. So it will check B is greater than or equal to 6 or not. If it is true, then the result will be true. Otherwise it will be false. If B is not greater than or not equals to C, then the result will be false. Okay. Same as like equal to. Suppose some K value equals to 50. So if K is exactly equals to 50, then only result will be true. Otherwise it will be false. Okay. Suppose K not equals to M. So if K value is not equals to M, then the result will be true. Otherwise, if both are equal, then the result will be false. Okay. Fine. These are relational expression. To build relational expression, use relational operators. So these are relational operators in AWK command or utility or programming. Okay. Next we will move to logical expressions. So these logical expressions will compare two expression values based on the two expression values. We'll take some example like A greater than B, and there is another expression like C less than 10. Okay, C less than 10. Okay. Now the requirement is like when this particular two conditions are satisfied, then only I want to do some operation. Okay, then in that case you can use logical expressions, logical operators. So these logical expressions uses logical operators to combine two or more expressions like this. Okay, so logical expressions, to build logical expression, use logical operators. We'll see what are those operators, and using these operators you can combine two or more expressions. So these expressions can be, generally it will be some relational expressions. Okay, fine. Now see this, when both are okay, means when A value is greater than B and C is less than 10, then only I want to do this operation. Then in this case you can use AND operator. Okay, so this AND operator, AND means when both are true, then only result will be true. If any one is false, then the entire result will be false. If any of these two expression value is false, then the entire result will be false. So first we will see what are logical operators, then we'll see how to use these. So in AWK command, logical operators are operations are AND or not. Operators are, for AND operation use operator double ampersand. Again these two are, AWK command will assume it as a single operator, even though if you look at, these two are separate, but there should not be any space between these two, and AWK will treat it as a single operator. Okay, so that operator is AND operation, for AND operation. So this is for AND operation. Okay, next to, for OR operation you can use pipe symbols, two pipe symbols. Again, there should not be any space between these two symbols. Okay, so this is OR operation. Next, NOT operation, AND or NOT. For NOT operation, use complement symbol or exclamatory mark. So this is NOT operation for NOT expression. Okay. Now we'll see some examples. A greater than B and B greater than C. Okay. Now see here, when this is true, I want to print A value. See this expression, if A greater than B and B greater than C, I want to print A value. So what does it mean? Out of 3, A is the biggest one. Okay. So if this expression is true and this expression is true, then only this will be executed. Means when two expressions are there, when both are true, then only the result will be true. We can see the diagram like how this AND operation will be done. Suppose there is an expression A. Okay, let me take this table form. This is for AND operation. I am taking two. One is expression A, another one is expression B. Assume that A is some relational expression, B is some relational expression. So a relational expression value can be only two. Either it can be true or false. Other than these two, you won't get any value in relational expressions. If it is an arithmetic expression, you will get some output like some numbers, integer numbers or real numbers, anything. Okay, but in relational expression, you will get only one output. That output is either true or false. Okay. In Unix operating system, the true will be represented with a digit, that is 0, and false will be with non-zero value. It can be any value, non-zero value. Okay, fine. So here A and B, I am taking two expressions. One is A, another one is B. So here there will be maximum 4 combinations. Like either A value can be true and B value can be true. Okay, so this is one combination. Another combination is like A value can be true and B value can be false. B expression value can be false. Next, A will be false or B can be true. And last combination, maximum we can get like, so this can be false and this can also be false. So here we have only two expressions. 2 power 2 means 4 combinations we can get max. Okay, so these combinations max we can get when you take two expressions, and if you evaluate those two, the result can be any of these 4 combinations. Okay, now if you perform AND operation between these two expressions, okay, so AND operation is nothing but when all are true, then only the result will be true. If any one is fail, then the entire result will be false. Here all are true, right? A true, B true. That's why the result is true. Okay. Now here, if anyone is false, then the entire result will be false. So here this is false. Because of this one will be false. Here also this is false. So entire result will be false. Here both are false. So the result will be false. Okay. Now we'll see the diagram for this OR operation also. In the case of OR operation, if anyone is true, then the entire result will be true. If anyone is true, if either expression value is true. Suppose if you take some 10 expressions and you are doing some OR operation between these all, then if any one of them is true, then the entire result will be true. Okay. See, max we can get only 4 combinations, that we know. Why? Because we are taking only 2 expressions. So 2 power 2 means only 4 combinations. If you take some 3 expressions, 2 power 3, maximum 8 combinations you can get. Okay, fine. Now, in the case of OR operation, if any one is true, then the entire result will be true. Here both are true, so the result will be true. Okay, so here A result is true, that's why the entire result will be true, even though the B is false, because OR operation. Okay, so here this one is true, B result is true, so the result will be false, true. So here in this case all are false, none of them is true, that's why the entire result will be false. Okay, if you take or if you see OR operation, so this is OR operation. Next we will see NOT. NOT means exactly opposite. Suppose A is true, not A means the result will be false. A is false, not A means the result will be true. Okay, we can see with simple diagram like NOT operation. So here max we can have so how many combinations we can get max? Only 2. The reason is here we have only one operand. For NOT operator it requires only one operand. Okay, so that is A. So not A. Suppose I am taking A value true, not A means it will be false. It will be false. Okay, so I am taking A is false, not A. Instead of this word I am using the symbol not A. Okay, so this will be true. Now see, there is one expression A. This not operator requires only one operand. Okay, so this operand is some expression, relational expression. Okay, so this relational expression is, I am assuming it as A. So this A value can be either true or false. If A value is true, not A means the result is false. If A is false, the result is true. Vice versa, exactly. Okay, so here these operators requires two operands. It is must. Okay, but here it requires only one operand. So these three are expressions. Okay, if you go back and see, we have different kinds of expressions. Right, so expressions, we have regular expressions, arithmetic expressions, relational expressions and logical expressions. We have seen what are regular expressions. So these are regular expressions. So this supports all grep, whatever the atoms or operators used in grep, everything will be supported in the AWK command also. Apart from these two, along with those, it supports these two operators additionally. Okay, so this is regular expressions. Next, arithmetic expressions. Arithmetic expressions can be built by using arithmetic operators. So these are arithmetic operators supported in AWK command. So these are all C operators. Whatever C operators are there, everything will be supported in AWK. So next, relational expressions. Relational expressions can be built by using relational operators. These are relational operators supported in AWK command. Again, these are all C relational operators. Okay, so in terms of symbol wise or operation wise, there is no difference compared to C. Everything is same. Whatever C relational operators are there, everything supported in Unix AWK command. So next, logical. So logical operations are AND operation, OR operation, NOT operation, AND or NOT. For these operations, you can use these operators. AND operator, OR operator, NOT operator. This NOT operator requires only one operand. Okay, so that operator, that particular operand can be generally a relational expression. Okay, so these are the operation, how AND operation will be performed, OR operation will be performed between expressions, and NOT operation. Okay, fine. So these are the expressions supported in AWK command. We will see one or two examples on this and we'll move to next topic. Okay, So how these values can be compared or result expressions will be evaluated. Okay. We'll move to our directories. Yes, sir. Last time, yes. Fine. So here this is one example for arithmetic. Here we are adding field 1, field 2, field 3, field 4 values and storing the result into T. So here this statement is built by using arithmetic operator, that is plus. Okay. So here you can use any arithmetic operator. Fine. Next we will take one example like no. Okay, fine. In this way also we can compare like equals to. We'll check first equals to relational. Suppose I am taking some a value 10. I am taking some a value 10. Now I am writing AWK space. I am writing inline script. Okay. So directly we can take in, no need of any option. Okay. So here if you are writing, if the script is available in a file, use -f. That f is small case. Okay. Small f for file. So here I am checking if a greater than 20, then only I am saying like print Okay. So here no need of any input file. So here we are not getting any output. The reason is a value is not 10 is not greater than 20. See how many lines are there? 13 lines are there. Okay. Now we'll take this example. If the file number of rows equals to some 13, then I'm going to display the values. Okay. So number of rows equals to some 13, then action is print. Okay. So print that line or print that entire line. Okay. So $0 to get the line, entire line, we can use this one. Next here the input file is names.txt. Okay. How many number of rows are there in this? Okay, 13 lines are there. Okay. This NR value is equals to, if number of rows, NR means it will give you number of rows. If number of rows equals to 4, so I am trying to display from 4 to 10 lines from this, comma, number of row, row number equals to, this is beginning address and ending address is, okay, we have to use double equals to for comparison. Number of row equals to, that particular row value equals to 4, this is beginning, and ending is like number of row equals to some 10. So here in this case we are trying to specify some address like number of row 4, starting address is 4, and 4 to 10. I want to display 4 to 10. Okay. So here in this case, instead of displaying the row number, I want to display the complete line. Okay. So entire row we can get using $0 from this file names.txt. Now see here, NR will get the row number. So if row number equals to 4, it is start going to display the row up to 10. So starting address is 4 and ending address is 10. So from 4th row to 10th row, it is going to display the row value from this file names.txt. So here from this names.txt, this is the 4th row. Okay, you can check in this file. So this is the file content, first row, second row, third, fourth. So from 4th row to 10th row, 4, 5, 6, 7, 8, 9, 10 up to here. So this is displayed. Okay. Now here we used some starting address and ending address. In this address we are using, instead of using the address, we are using some relational expression, that is equals to or not. If the row number is equals to 4, it will start printing. Okay, it will print the row. So up to ending address. So from 4th row to 10th row, you are going to display the row information by using this command. Okay, so here we used some relational expression. Okay, next one, along with this one, if you want to display the row number as well, then you can say NR capital. So these are all system variables. NR row number it will give you. Okay, see here, first 4, it displayed some 4, next row information. So first row number, next row information. If you want to display some gap between these, then you can write the statement like okay. Now see here, NR means it will display row number. Okay, next some space will be displayed. So space is nothing but it is a string. That's the reason we are placing in double quotes. Next to $0 means it refers the row. $1 field number 1, $2 field number 2. So in that way, so $0 is nothing but entire row. Okay, you can access entire row. Now here row number and space. Okay, fine. So in this way we can use relational expressions by using relational operators. So these are the relational operators, relational logical operators and arithmetic operators in AWK command. Okay, so we'll see some small programs later. Okay, so next topic, actions. Again, if you see the AWK command syntax, so this is AWK command syntax. Options, we have only two options, capital F and small f. Capital F, it is input field separator, small f, script file, right? So script, what is the syntax or form of appearance of the script? The script appearance is, it can be inline or in file. Okay, so it contains pattern and actions. So we have seen different patterns. So the pattern can be regular expression, or it can be some arithmetic expression, or anything. Okay, so it supports all the patterns, okay, like grep patterns and regular expressions, arithmetic expressions, these are all. Next we will see what are the actions present in this AWK command. Okay, so actions are like nothing but statements. Actions are nothing but statements. Suppose we used some print $0. It is going to do some action like printing the values. Printing the values. Okay. Suppose see this action. See here this is one statement. It is going to do some action like adding 4 field values and storing the result into t variable. Okay, so this is one kind of action. Okay, so action is nothing but it is a statement. It is a statement. So okay. So action is nothing but it is a statement. It is going to perform some operation or action. So what are the different statements? We have different kinds of statements, but your statement can be a single line statement or it can be multiple lines of statement. Okay, so here if you see the previous example, see here this is one statement. We placed it in open and close curly brace, right? So this is another statement. Okay, if you want within this flower bracket you can write more than one statement as well. Within this open and close flower bracket you can write more than one statement. Like see this is the beginning, pattern beginning, and this is pattern ending. Between these if you want to write more than one statement, terminate that particular statement. See this is one statement, one. Okay, I want to write more number of statements. Press enter and write your next statement. Statement 2. Press enter, statement 3. So like this you can write any number of statements. Any number of statements between open and close flower bracket. Okay, so here your pattern will present. Okay, so this pattern, beginning of this pattern, when this particular pattern is found, all these statements will be executed on that pattern, on that particular record. We can say record or line. Okay, so when this pattern encountered or found, all these statements will be executed on that particular record. Okay, or your statement can be a simple single line statement. So your pattern, next statement, close. Okay, so when this particular pattern is found, this statement will be executed on the row. Okay, so this is one statement action. So this is multiple statement action. To write multiple statements, use new line character, means after writing one statement, press enter key. Another way of writing multiple statements is, so this is single line. Okay, so this one is multiple lines. Multiple lines of writing statements. Okay, so this is one way. Another way is, I want to write multiple statements but in a single line. Then your statement will be like, so here first your pattern will present. So this is beginning of the statement, statement 1, and this statement with semicolon. Next statement 2, statement 2 and with semicolon. Okay, next statement 3. Like this you can write any number of statements. Suppose in my multiple statements I have only 3 statements, then your statement 3 need not to be terminate with or end with semicolon. It is not must, it is not compulsory. Okay, if you are going to write another statement, then terminate the statement with semicolon and start writing next statement. Okay, so this is last statement in my list, then end with close curly brace. There need not to be a semicolon. Here there is a small difference between C and AWK multiple statements. If it is C language, irrespective of it is single statement or multiple, and every statement with semicolon, that is C language rule. But here in AWK command, if you are writing multiple statements in single line, then end every statement with semicolon, and your last statement may or may not be end with semicolon. It is not compulsory. Okay, you need not to end with a semicolon. That is the difference. Okay, and next we'll see what are different statements. See, if you see this example, yes, if you see this example, here we have two statements. Here we have two statements, and these two statements will be executed on every row or every record in the input file. The reason is no pattern present, right? So before this open curly brace, is there any pattern? No pattern. So this will be executed on every record in the file. This is one thing. Next one is, here if you see this particular thing, here it is going to add 4 field values and storing the result into some variable. Here it is going to do some other action like printing the t variable value. Printing t variable value. This expression is some arithmetic expression. This expression is some arithmetic expression, and this one is some output statement. Means it is going to output some variable value. Okay, so like this we have different kinds of statements. We'll see what are those kinds. So your AWK command action statement can be an expression. Expression is nothing but it can be some arithmetic, generally arithmetic statements only. So arithmetic or some relational we can say. Okay, so relational is nothing but like, okay, we'll see. So some expression, or it can be some output statement. Output statement is nothing but it is going to display some output, variable value or some string output, whatever it may be. Okay, so again these output statements are we have in AWK command or print. Already we used this particular print. It should be in small case, lowercase print, print. It is a output statement used to output some string values or a variable value. Okay, it is used to output some results. Okay, next one is printf. So it is exactly similar to your C statement. In C also we have output statement printf. Okay, the same one we can use here. Next to sprintf. Sprintf. This is also C statement. Okay, so next one is decision. Your statement can be a decision statement like if statement. In C language we have if else. So these are decision statements. So here based on the decision you are going to execute some statements. Okay, fine. Next looping statements. So in AWK command we have some looping statements like while loop, same as C language, for loop, syntax is different but the functionality is same as C language, do while loop. Okay, so here while, do while, for, these three are looping statements in AWK command. Okay, next one control statements. Okay, we have control expressions also. We didn't discuss about this one in depth, but we have control statements like next, it will move to next line, and get line and exit to terminate. All are small case only. So these are the different statements in AWK command. Expressions like arithmetic expressions or output statements, it can be a print or printf or sprintf. Already we used this output statement, right? Next one, decision statements, if else, looping, while loop, for loop, and do while loop. These three are looping statements in AWK command. The functionality of these commands are similar to C, but the syntax is a little bit different. Okay. Next, control statements. These three are control statements. In the coming session, next session, we are going to discuss about one by one all these statements. Okay. So what is expression? What are the output statements? How do we use? Already we used one output statement, that is print. Okay. So what is the syntax of this printf? How do we use this in AWK command? That we'll see in the next session. Okay. So already we used this print statement, right? Here. Let me check. Grep, which begins with marks. Okay. Yes. So this marks.txt file contains only some numbers, columns. 4 fields are there in every record. Suppose I want to print only first and second field values from this file. Then you can write the statement like AWK, using AWK command. I want to display only first two. Only first two. Here the requirement is only print first two fields. That's all. Okay. Then AWK, we are going to write inline script. Okay. So no pattern. Directly we are going to write some action. I want to print field value. Then use output statement print field value 1, that is $1. You can refer the first field with the $sign and that field number, space $sign and field number. Okay. So it will print only first and second fields from the file marks.txt. Okay. So these two fields, only first field and second field. Okay. So here if you want to display while outputting, if you want to display whatever the field separator is there, if you want to display that field separator also, then you can display by using, you can display that by using some begin action. Okay, like AWK space. Here I am going to write some begin action. So this will be executed before going to do your actions. Okay. So here this is begin action. Here output field separator. We have one system variable, that is OFS. This is output field separator. So we are specifying this output field separator equals to some tab space. It should be small. Okay. So tab space \t, that is nothing but tab, / characters, these are all, \n, new line character. Okay, fine. So \t and this. Okay. Next one, we are going to specify some action item. So this is begin. There is no end. We are going to do some operation like from this file I want to display only two fields. So use print statement. Print is going to display some outputs. Okay. So I want to display $1, next to $2. $2. Now close this one. Input file is marks.txt. Oh, here $. Okay. Oh, this should be in double quotes. Here another syntax is double quotes. Okay. Now see, output field separator. By default it will display without any spaces. Okay. So this first field value, second field value. Okay. No space. Without any space it will print. Right. This comma is not mandatory. Okay. So without any space it will display the result. So while displaying the result, If you want to specify some field separation, then use system operator variable. So that is variable OFS, output field separator. Okay. So here we use tab space. Instead of that, you can use, like suppose I want to separate with your input field separator is tab space, but I want to change this one. Your input field separator is tab. Okay. So here I am going to change in my output. Means I want to separate with pipe symbol. That you can do using system variable OFS. This is AWK reserved variable. Okay. See this, these two are separated with pipe symbols. Okay. In your input file, tab is the field separator. Tab is the field separator that you can change using this OFS. Okay. So now this print is going to output some results. Okay. Fine. In the next session, we'll continue with expressions we have seen, printf also we have seen. Next we will continue with printf and sprintf. This printf syntax is exactly similar to C syntax. Okay, like printf. There are some two variables A and B. I'm going to display these two variable values. Okay, printf %d. These two variables A and B are integer variables. That's why I'm using %d, %d, comma A, comma B. Okay, so here I am going to display A, B variable values. So these two variable values will be outputted without any spaces or something else. Okay, then you can format, like here you can give some space. Now between A and B, in this percentile, first percentile D position, A value will be displayed. Next some space will be displayed. Next in this percentile D position, B variable value will be displayed. So this syntax is exactly similar to C syntax. Like suppose if you are displaying some real variables, use F. Assume that A is real variable and B is some integer variable. Then percentile F for float. Okay, and you can control the decimal places also, like 4.2. 0.2 is the number of decimal places you are going to output. By default it will display more than 2 real part. Okay, means after point some fractional part, real part will be more than one digit will be displayed by default. You can control by using some format. Okay, so you can output your format as in the C language. Okay, so your syntax for printf is similar to C, sprintf is also similar to C. Okay, that we'll see in the next session. Okay, what are decision statements and what are looping statements, how do we use these, that we'll discuss in the next.